In this video, we are going to learn how to write an equation of a line that is parallel to another given line. Parallel lines are lines in the same plane that never intersect. They have the same slope, but different y-intercept. Let's look at this example. Write an equation for the line that passes through -2 and 5 and is parallel to the line described by y equals 1/2 x minus 7. So the key word is parallel to this line right here. Since I know they are parallel, then I know that they have the same slope. So I'm going to take this 1/2 and use that as the slope of the line I'm trying to write the equation for. Now I have all I need. I have a point and the slope. So I'm going to start with the point slope form, which is y minus y1 equals m times x minus x1. All right, so the slope is 1/2, y is 5, x is -2. So let's get started. Y minus 5, all right, that's the number I use, equals 1/2 times x minus -2, which is x plus 2. You can leave the equation in point slope form, or you can turn it in slope intercept form, whichever way you prefer to see it and understand. That helps you understand it better. Or look for directions, read directions carefully, because sometimes they will specify what form you need to write it. Let's take a look at this other example. Again, write an equation for the line that passes through point 4, 10, and it's parallel to the line described by y equals 3x plus 8. I know that parallel lines have the same slope, so the slope of the line I'm trying to write the equation for is also 3. So I will start with point slope again. Y minus 10 equals 3 times x minus 4. Okay. I can stop here, or I'll take this example one more step and I will change this point slope form equation into a slope intercept. So let's start by using the distributive property to get that x minus 4 out of those parentheses, so 3x minus 12. And then I add 10 to both sides, plus 10. That cancels. Y equals 3x minus 2 is the equation of the line parallel to the given line. As you can see, 3x is the same for both lines, and the y-intercept for the given line is 8, and the y-intercept for the parallel line that we just found the equation of is -2. Now let's take a look at the perpendicular lines. Perpendicular lines are lines that intersect to form right angles. The slopes of perpendicular lines are opposite reciprocals. What that means is if one line has 2/3 as a slope, the slope of the other line, the perpendicular line, will be -3/2. Okay, for instance, if you have a line that has 1/7 as a slope, then the opposite reciprocal of it will be -7/1, or simply -7. So keep that in mind. Write an equation for the line that passes through these points, and it's perpendicular to the line described by y equals 1/3 x plus 5. Now, since the lines are perpendicular, I'm going to look at the given slope, 1/3, and the opposite reciprocal of it will be -3/1, or simply -3. Now I have 1 point and the slope for the new line, or for the perpendicular line. So I will start again with a point slope form. Y minus -2, which is y plus 2, equals -3 times x minus 1. Again, you can leave it in this form, or you can turn the point slope form into a slope intercept form. please look at the directions, whatever the directions tell you to do, or if there are no directions, then leave it the form you prefer to leave it. Example 4. Again, I have a point, and it's telling me that those two lines are perpendicular, and one of the lines I know the equation of already. So looking at the slope here, negative 2/3, the perpendicular line to that, the slope will be a positive 3/2. I will start with y minus 6 equals 3/2 times x minus negative 4, or simply x plus 4. How about we turn that into a slope-intercept form so we don't forget the process? So y minus 6 equals 3/2 x. I'll multiply that x by each term inside, plus 6, because 3/2 times 4 equals 6. Now I solve for y, plus 6 on both sides to cancel that 6. So y equals 3/2 x plus 12. Take a look at this line, the new line that the perpendicular line to the given line. The slopes are opposite reciprocals. One more type of example. You are going to get two equations, and you need to identify the slope and tell whether those lines are parallel, perpendicular, or neither. So if the numbers are the same, the lines should be parallel if the slope is the same. And if the slopes are opposite reciprocals, the lines are perpendicular. And if the slopes are not the same number or opposite reciprocals, the lines are neither parallel nor perpendicular. So let's take a look at these examples. In the example 1, we don't have to do much work because they are both in the same form and I can easily see the slopes. 1/7 and negative 7. You can see this negative 7 as negative 7 over 1, so it looks like 1/7 and negative 7 over 1 are opposite reciprocals. So yes, these two lines are perpendicular. Okay, now let's take a look at this other example. The first equation is in the slope-intercept form and the second in standard form. So I'm going to have to work on this a little bit. I will turn this equation into slope-intercept form too, so I can easily see the slope, minus 4x, minus 4x, and this cancels. So we have negative y equals negative 4x plus 2. I will solve for y because I don't need the negative y, I need the positive y. So I can either multiply by 1 all the terms or divide by negative 1, I apologize, by negative 1 all the terms. So I get y equals negative 4 divided by negative 1 would be positive 4x, and then this would be negative 2 or minus 2. So comparing the two slopes, the first slope is 1/4 and the other one is 4. 4 is the reciprocal of 1/4. However, it is not the opposite reciprocal because it's a positive 4. You look, both signs are the same. So no, these are neither parallel nor perpendicular. Okay, let's take a look at the last example here. Again, you want those both equations to be in the same form, so intercept form. So let's get started. Subtract negative 2x from both sides. All right, so we got y equals negative 2x minus 5. Now, taking a look at the slopes, they are identical. They are the same number, just the b or y-intercept is different. So in this case, we can say that these lines are parallel. Okay, this is it. If you have any questions, please let me know.